Okay, we have a pair of Ritron data modems, and they are running on 220 megahertz. And this is the field unit, and this is the actual master. And it's transmitting right now at a temporary frequency of 218 megahertz and receiving 218. It's only kilohertz apart. So what we did was we wrote a Python script to control every second it's going to send a packet over here with an ID, and then the actual field unit's going to pick up that packet and it's going to attach and send back the packet ID it received plus the RSSI signal, or the signal strength. And then this unit, again, it's going to receive, as soon as it receives its packet plus it's going to take the signal strength it got from that particular packet, and then it's going to append it to the actual data. So you can see here it's writing a common delimited file. This is just some text to let us know that it's working, but you can see the actual ID of the packet and the signal strength that it received. And at the field unit, this is the signal strength it received, the time stamp, and then the signal report it got back from the field unit. So, or the signal strength that it actually received from the transmission. So this right here is actually controlled by an Arduino, and the Arduino actually pulls it off of these particular older modems didn't have an RSSI pin out on the actual 15 DIN adapter. So the Ritron was nice enough to give me the schematics and tell me which pin number it was from, the RSSI is on. And I went ahead and hooked that up to pin 5, which wasn't connected to anything. And so the Arduino actually takes the signal, which is an analog signal, and then it converts it and then sends it back as a digital format. So this particular unit only has Anderson power poles, 12 volts, meant to be used on a battery. We have a couple of antennas, different antennas that we're going to use for this. But if we go ahead and take the antenna off of this, we're going to go ahead and see that the signal strength, I'll do this very quickly because I don't want to blow out the receiver on this, but you can actually see that the signal strength is actually going down quite a bit. I mean, it's right next to each other, but it's actually going down quite a bit from 477 to like 390. I'm going to go hook that antenna back up. And so this is going to be meant for driving around to see how the signal strength is in different locations, how far away it goes. And so this Ritron's actually hooked up through 2 serial ports. One's an actual COM1, the other is a USB to serial. So one actually is sending the data and the other one's actually receiving the signal report. And so again, this Python script was written, and it's using PySerial, and it's a very small script, and it collects the data and it will put the data on a common delimited file on a USB memory drive. And that's it. So this is the project to be able to take care of signal strength, and it can be used for any type of radio. The Ritron radios are really great, very, very well designed, and somewhat bulletproof, but the designs are really, really great. So I can't wait to get some new ones, some of the newer models that they have, be able to use them for testing purposes as well. All right, thank you very much.